In this lecture, we are going to learn how data type conversion is done in C. Basically, there are two types of conversion that happens in C programming. The first one is called as implicit type conversion, also called as typecasting, wherein the compiler will automatically change the type of the data while executing the expression. And the other one is called as explicit type conversion, wherein the programmer has to manually give a command or provide the instructions so that it can do the type conversion. So let's try to demonstrate the same using an example here. So here x and y are integer variables, and what I have done here in this expression line number 10 is that I am adding the character a with 2. Now you may be thinking, is it a valid expression here? Right? This one is a valid here because I've already discussed that a would be internally represented as an integer value. So this will be automatically be treated as an integer value. 2 is added to that. Okay. So if I just print the output for this, printf x equals to %d, and if I print x, let's see what is the output. Okay. Let's compile this code and let's run this now, a.exe, and I get it is 99. How come the answer 99 is displayed here? It's very simple. So ASCII code of A is 97 and 97 plus 2 is 99. This is also kind of a promotion, right? This has been promoted to integer, right? And integer is added with integer. Okay. So this is how this addition is done. Now let's try to see one more example. Let me create one variable called as double. Let's call it as P, and I write here P is equals to A plus 2.2. Okay, so here what I'm trying to do is I'm adding character a with 2.2, right? So let's see what happens here. Answer P equals to %lf because it's a double value, right? And I print P. First of all, let's see what is the output for this expression, and there is no error here. Okay, and let's see what happens here, and I get 99.20. So what is happening here is that a is actually a character which is represented as an integer value. So let's consider a as ASCII code of a, which is 97. So a is treated as 97. So it is 97 plus 2.2. So here we are trying to add two numbers of different types. So the first number 97 is of type integer, right? And the second number 2.2 is of type double, right? So whenever you add double and integer together, automatically what does the compiler do is that compiler will automatically promote this integer 97 to double. So 97 will now be treated as 97.0, that is double value, plus 2.2, and then the answer becomes 99.2. Okay, so this is how it works. So in this case, whatever conversion happens, right, here the integer is promoted to double, and this is automatically done by compiler. Okay, so done by the compiler. So this is called as implicit type conversion. Automatically the compiler implicitly does the conversion for us. Okay, we can take one more example here. If you just look at this is sort int. Z is sort int, which is storing the value 2, and I'm y. What is the type of y? Y is integer. Just note it down here. Y is an integer value. Okay, so I'm trying to add integer with sort. Okay, so I'm trying to do int plus short. So there are different types, although both of them are representing integer. So what happens is that it will first check the rank. The rank of sort is obviously narrower than the capacity of int, right? Integer is always having wider capacity than the sort value. So what happens is that automatically this sort will be promoted to integer. Okay, promoted to int. So that is automatically done by the compiler. So now if I try to print the value, answer y equals to %d, and now if I just print the value of y, I should be able to see the value of y. Compile it and execute it, and you see the y is 14. Alright, so this is a type conversion rank. This is a rank of data types based on the how narrow or how wider is the data type. So the narrowest or the lowest rank is of char, char is of lowest rank, and long double is of highest rank. So whenever the compiler finds an expression wherein you have different combinations of different data types, it will make sure that the data type of lower order, lowest rank, will be promoted to the data type of highest rank according to this particular example. Okay, now in this case, if you just see here, there is an example here wherein a, b are integer, right, and this is an expression that is to be evaluated. Okay, now in this expression, if we just, let's go from left to right here, this is long. Okay, this is long type because this is 2l, this is a long int, and this is actually a is int, right? So this is actually also converted, this int will be promoted to long because this is of long, so it is like long divided by long. Okay, so finally the answer of this is also in long, correct? Now just look at this, 16 times c. Now c here is float, okay, and 16 is obviously it is integer, so integer times float, so integer is of lower order, right? Int is of lower order, float is of higher order, so integer will be promoted automatically to float, implicit type conversion. So this will be converted to float. So now it is float 16 times float 6. So finally the answer is also in float. And finally d, right? D is nothing but d is double here, right? So d is double type. Okay. Now finally what I'm trying to do is I'm trying to add long plus float plus double. So lower order, highest is of type double. So long will be converted to double. Okay. Float will be converted to double. Now don't be confused, how does a long value get converted to double? Let's say the long value is 1, 2, 3, 4, 5. How does this convert to double? Just by putting dot 0. That means it will be 1, 2, 3, 4, 5.0. Okay, this is how long is converted to double. So this is long is converted to double, implicit type conversion. Float is converted to double, implicit, and this is double. So double plus double plus double. So answer is also double. Okay, answer is also double. So finally the answer for this entire right hand side is in double. But my left hand side variable is b, right? B is of type int, so this can only hold, b can only hold of type integer value. So this double value, let's say the double value is 12693.82. In this case, because b can only hold the integer part of this, so there is no rounding of done. So this is all not stored for me because int can't store this value. So finally the answer is 12693, that is being stored in the variable b. That is the output. Okay, I hope you have understood this table. Now let's learn about the explicit type conversion. Let's write the comment here, explicit type conversion. Let's take an example to find the average of two numbers. Okay, let me have declare two numbers here, in num1 comma num2. Okay, these are two numbers. Let me assign number 1 is as 5 and let's say number 2 is 2. Okay, and let me try to find the average of these two integer numbers. So obviously average will be a double value, or we can say it's a floating point number. So I can write double avg, it will store the average. So I'll just write avg, which is average, is equals to, I have to add two numbers, that is num1 plus num2, and then because there are two numbers, so I divide by 2. So this is how I get the average. Actually what I'm doing is I'm trying to add 5 plus 2. 5 plus 2 is 7, right? So 7 divided by 2, I should be getting the answer as 3.5. Okay, so let's see what is the output. Printf avg equals to percentage lf, because I'm trying to store in average avg is of type double, so I write avg here, the variable name, and I'm done. Okay, so let's just compile this code again and then run this. So you see the answer is 3.0 and it's not giving me 3.5. okay, which is the correct answer. So why did I get 3.0 here? Now to understand this, we have to first of all understand this avg example here. So this is the example, num1 is of type int. So let's say this is a num1, this is a storage box wherein inside the memory 5 is stored, right? Similarly, one box is created. This is called as num2, where the value 2 is stored. Okay, and there's one more box, a bit wider box, because this is of type double. This is avg. Okay, this is of type double, wherein I will be storing my average value, and both of these are of type integer. Okay, so now evaluation happens from obviously right hand side, only then the equals to will be evaluated. So first, according to our rule, precedence rule or the priority rule, first bracket will be evaluated. So num1 and num2 would be added first. So this would give me 5 plus 2, which is 7, right? Divide by 2. This is as good as writing 7 divided by 2. So here in the right hand side, I'm in the right hand side now. So I'm trying to divide integer number by integer number. So whenever you divide integer by integer, obviously the answer is also integer. So whenever I divide 7 by 2, whenever I use the division like this will give me the quotient. So 2 times 3 is 6, remainder is 1. So the quotient here is 3. So the answer for this entire thing is 3. And 3 is assigned to the variable AVG. AVG is actually double, so it will be making it as 3.0. Hence, you will get the output as 3.0. Now, how do you make sure that you will get the exact answer, which is the correct answer, that is 3.5? In that case, what you do is, you have to either make this one as float or this one as float or double. Okay. So, what I do here is, let me change this to 2.0 and let's see how it behaves in the program. So if I make this as 2.0, so this would be treated as double. 2.0 is double. So obviously this entire thing is integer. So integer is now automatically, implicitly promoted to double. So double divided by double, answer is double. So I should get the correct answer here. This is implicit type conversion. This is not explicit. Just remember that. Let me compile this and let's execute it. So I get it is 3.5 as the correct answer. This is still implicit type conversion. Okay. Now let's get back to 2. So now let's see how we can apply explicit type conversion in this expression to still get the answer 3.5. Okay. Now what is explicit type conversion is that we as a programmer, we can forcefully change the type of a data type or a variable or a constant. Okay. So here I'll try to change the type of integer from 2 to 2.0, that is double. Okay. So forcefully change type of 2 to double. So to do that, what I do is I'll use a syntax. There's a syntax that I have to follow. That is, I'll give the type name and here whatever expression is there, right? So whatever expression is here, that will be converted to this type. So I want to convert this constant to the type double. So what I do here is, just before double, I'll use a bracket like this. This is the rule. This is the syntax for doing the type conversion, explicit type conversion, and here I'll write double. So whatever may be the type of 2, compiler will try to convert that to double. Okay, we are forcing it to convert to double. So this will be double 2 and this is integer, right? So this is integer and this is double now. So if this is double, now using implicit type conversion, this num1 plus num2 also will be converted to double. 2 is explicitly, user is converting, user here is a programmer, user is converting this 2 to double explicitly, and num1 plus num2, which is integer, will be converted to double because this right hand side, the right hand operand of division is also double. So both of them will be converted to double, one implicit, one explicit. And now if I compile this, now I'll get the output as 3.5. Okay. I hope you have understood how explicit type conversion has to be done. Now we'll see one more example to actually see how we can use this type conversion. Okay. Let me create two variables, double of type double, p comma q. Okay. Let p be 5.6 and q be 2.2. Okay. Now let me try to find out the remainder of dividing p and q. So let me write rem is equals to p mod q. That means I'm trying to find the modulo of p and q. That means I'm trying to find the remainder of dividing 5.6 by 2.2. Okay, what would be the remainder? Now if you can recall, we have already told that modulo only works with integer. Okay, so it will not work with any floating point number, not with float, not even with double. Okay, so let's see what happens if I compile this code here. So it says that this is not a valid operand for modulo, it should be of type integer, right? So what I can do here is, I can, if I have to find out the remainder here, what I can do is I can forcefully change the type of double to int. So I can make this as int, okay? And if I just make this, the first one as int, what happens? Let's see. So first one is made int, but second one is not made int, right? Because it will not change the higher order to lower order in implicit type conversion. It will not be implicitly, double will not be implicitly converted to int. That is, lower order transmission is not done, conversion is not done. So here I'll have to individually convert this q also to int by writing int, okay? And now let's try to compile this. You see, now double q, previous declaration of p. Okay, p is here it is saying that previously P is declared somewhere. Is it so? Yeah, P is being declared here. See, double P. And I'm trying to redeclare it again here. Okay, so that is not allowed. I cannot redeclare the variable. Okay, so I already have created the variable. So declaring a variable is done only once. So I've already declared P in line number 10. So I need not redeclare it here. So I'll just write double Q, and I can use the same P. I'm overwriting it by 5.6. Okay, so now let's try to compile this and a.exe, and now okay, I did not print the reminder, so I'll just do printf reminder equals to %d and comma rem. Okay, before we run this, let's make this reminder as an integer, because our reminder is an integer value, integer number. Okay, so let's try to compile this code. So now I get the reminder as 1. This is because now this 5.6 will be converted to 5. Okay, 5, and I have mode, and 2.2 will be converted to 2. So if I divide 5 by 2, quotient is 2 and remainder is 1. Okay, 2 times 2 is 4 and the remainder is 1. So that's why I get the remainder as 1. Okay, so I hope in this video you have learned how to do the type conversion in C, what is implicit type conversion, what is explicit type conversion, and wherever required, please make use of this. And whenever you get error messages like this, we have got many error messages here, right? You should be able to read down the error message and then go and fix it. Okay? Do not worry about the error messages. Error messages are our friends. I've already told you. You have to go to that line number and then see and read what is the error message and try to fix it. Okay? So that's all in this lecture. Stay tuned.